Good morning, everybody, or good afternoon if you're doing your notes in the afternoon. We're going to go ahead and move on with our notes. I know it's going to be a little difficult, but I am doing this screen recording in the hopes that it will give you some sense of normalcy for school, because I'm going to go through this just like I would go through your notes as if we were face-to-face, okay? So yesterday we talked about distributive property, and today we're going to talk about factoring expressions. And now here's the thing you got to know about factoring expressions. If you see my little Uno card over here, it's because factoring expressions is the reverse of the distributive property. Okay, so you got to think of distributive property as going forward, and then factoring is going to be going backward. Okay, so when we factor, we're going to use something that we already know how to do. I wonder if you can find it somewhere on the page. Can you guess? We're going to be using GCF. I know you guys are so excited to bring that back because, in fact, we're going to use the same SLED method that we did with GCF and LCM. We're going to use that same method for factoring expressions as well. Woohoo! I know you're so excited about that. So let's go ahead and get started, okay? Now remember, these are your steps, and you should be using this as a checklist, okay? Because that's what it's here for. It's here to help you see, all right, step 1, I've already done that. Step 2, I haven't done that one, so that's the step I'm on. It's to help you stay organized, and it's also to just make sure that you don't skip anything, okay? So the first step that we're going to do is we're going to find the GCF of our terms. Okay, so find your GCF. Super easy. Again, if you can't see the big GCF, always start small. Typically 2 and 3 will 9 out of 10 times always work. Okay, so that's step 1. Step 2 is going to be to divide each term by the GCF. All right, so you're going to divide each term by your GCF. Now, the word we would actually use here is factor. We're going to factor each term by the GCF, but that's really just a fancy way of saying divide, okay? So just know that. Once you factor out all your terms, once you divide all your terms and you get down and you can't, divide out the same number anymore, you're, at the simplest form that it can go to, you're going to rewrite your expression. And the way that you're going to do that is you're going to place your GCF outside the parentheses. And the remaining terms, meaning the two things that are left over on the bottom of our sled, those are going to go on the inside of our parentheses. Okay, so the GCF is on the outside, your remaining terms will go inside. All right, and then what you can actually do is you can distribute. So use the distributive property, distribute to check. All right, so if we needed to go back and check our answers, we would just go use the distributive property. So that's what it's going to look like, okay? So if you think back to what the distributive property does, this is usually our end results of the distributive property. We have like two numbers being added together or two terms being added together. So what we're doing is we're taking those two terms that are being added together and we're working backwards to make it look like what distributive property started with, which was the number on the outside of the parentheses and then some things on the inside. All right, so to do that, we're just going to put the whole shebang on a sled. Okay, so I'm literally going to put a sled right under 36 plus 42. Now, I need to think about what number can 36 be divided by that 42 can also be divided by. Now, I automatically see the number 6. Okay, so I'm going to do 6. If you didn't see 6 and you saw 2, do 2. That's 100% okay because we'll get to the same answer so long as you go all the way down. All right, so I'm going to pull out a 6. And I know that 36 divided by 6 is 6. Okay. I'm going to bring down my plus sign. That's just going to come down the whole way. And then 42 divided by 6 is 7. All right. Now there's no number that I can divide 6 by that I could also divide 7 by, so I'm done. Okay. Now GCF is on the left. And then 6 and 7, which is our remaining stuff, those are what we're going to need as well. Okay. So remember, GCF is on the left. And then at the bottom is going to be all of your remaining stuff. I would circle those two things because you're going to need them when rewriting your expression. All right, so let's look at it. So if you remember, step 3 said take your GCF and you're going to write it on the outside of the parentheses. So 6, and then I'm going to have an open parentheses. But then on the inside, it's going to be whatever was left over, which was my 6 plus 7. So I'm literally just going to take it and write 6 plus 7 and close parentheses, and then you're done. That's all you're doing, okay? Not super difficult. All you're doing is dividing, really. Now, if I wanted to check it, again, like it says, I could just use distributive property to check. All right, so I would give 6 to 6. Remember, giving is to multiply. So 6 times 6 is 36. Bring down my plus sign. I'm going to give 6 to 7. Again, to give means to multiply. 6 times 7 is 42. Is that not what I had up here at the beginning? It sure is, so that means I did it right. Okay, so 6 parentheses 6 plus 7 is your final answer. Okay, now let's look at another one. All right, let's do 9x minus 18. All right, again, put the whole shebang on a sled. What can 9 be divided by that 18 can also be divided by? Hopefully you see that both of them can be divided by 9. Okay, if you didn't and you saw 3, again, go ahead and do 3. I will go ahead and do 3 just to show you what it looks like if you have extra steps. Okay, so say I saw a 3. I'm going to pull out a 3. Okay, well, what's 9 divided by 3? It's just 3. So what would 9x divided by 3 be? It would just be 3x. You're still dividing the same, just like with distributive property, you're still multiplying the same. This time you just happen to have an x. Okay, so that's how you work those kind of problems out. You still just divide as normal or multiply as normal, and you just bring that x down with it, okay? We're going to bring down our minus sign as well, okay? And then I'm going to look at 18 divided by 3. What is 18 divided by 3? Well, that's 6, okay? So then I'm at this next step, and I should always be asking myself, can I go further? Is there a number that I can divide 3 by that I could also divide 6 by? Well, yeah, there is. It's 3. So I'm going to put 3x minus 6 on another sled, okay? And I'm going to divide those, again, by 3. So 3x, again, what's 3 divided by 3? Oops. 3 divided by 3 is 1. So you can just write 1x, or you just write x, because that x technically has an invisible 1 in front of it already, all right? So 3x divided by 3 is just x. All right. If you want to put the 1 in there because it's going to confuse you, put the 1 in there. I don't care about that. Bring down your minus sign again, and then move on to your next number. So this time it's 6 divided by 3, which is, very good, 2. Now I have technically 1 and 2 are my two numbers, and there's nothing I can divide both of those by. So I'm done now. Okay. So again, remember, GCF is on the left. I want to circle everything on the left because I'm going to need all of that. And then LCM is and then what's left over is going to be on the bottom. So I'm going to circle that because I'm going to also need that. So step 3 says to write your GCF on the outside of your parentheses. Well, how do I find GCF if I have two numbers? Do you remember? Very good. You should multiply them. So 3 times 3 is 9. And that's what I'm going to write on the outside of my parentheses. So I'm going to write 9, open parentheses, and whatever's left over, which is my x minus 2, will go inside the parentheses, and that's my final answer, 9 times x minus 2. Seem easy enough? Well, maybe not super easy, but it's something that you already know how to do. Remember, this is just division. That's all you're doing is division and maybe a little multiplication if you have multiple steps. So I want you to go ahead and pause the video, and I want you to try this problem on your own, okay? All right, welcome back, everybody. We will go over this problem together in class on Monday if we are back together. If not, as soon as we get back together, we'll go over that answer as a class. So I'm going to go ahead and skip to the next page. So this is your back page, if you'll turn over. So factoring expressions doesn't mean I can just factor out a number. Sometimes I can factor out a variable as well. So sometimes I can factor out a letter too. All right, but it's done the same way. Okay, so you have to make sure that both of your terms has that variable. Otherwise, you can't just factor it out. You can't just divide it by 1. You have to divide it by 2. So let's take a look at those, okay? So if I'm looking at 10y minus 25xy, I'm sorry, I'm going to put both of those on a sled. Now let's start with our numbers. What's a number that 10 can be divided by that 25 can also be divided by? 5. So I'm going to pull out a 5 and I'm going to write it a little over here so I can give myself some space, okay? So I can pull out a 5 out of both of those. Well, now let's look at our letters. Let's look at our variables. Is there a variable that both of those terms have? Well, yeah, a y. So I'm going to pull out a y. So instead of just factoring out 5, now I'm going to factor out 5y. And again, the process is the exact same. I would always start with your numbers because that's super easy because we know how to divide with our numbers, right? So like, let's look at this first one. 10 divided by 5. What's 10 divided by 5? Duh, 2. So I'm going to write a 2. Okay, but now, so you have to think of this as this 10 has one y, or has a y next to it, right? It has one y. Well, if I'm taking out one y, how many y's does this 10 have now? Well, none, right? Because I just took it away. So this 10y divided by 5y is just going to be 2. It's not 2y, it's just 2 because I took away that y. All right, so it's basically like saying y divided by y is 1, and we don't have to write the 1. So it's just 2. So I'm going to bring down my minus sign, and then I'm going to move on to my next number, okay? So 25 divided by 5, again, always start with your numbers. 25 divided by 5 is 5. All right, now I have xy. Again, I have one x and I have one y, but all I'm pulling out is a y. So what am I left over with? I'm just left over with the x, right? Very good. Again, y divided by y is 1, and I don't have to write that. So I would just write the x, which is what's left over. Now, can I pull anything out of 2 and 5? Can I divide 2 by a number that I could also divide 5 by? Nope, I can't because they're both prime numbers, so I can't divide either of those by something. And none of them have, only 5x has an x, 2 doesn't, so I can't pull out a letter, so I'm done. Okay, so again, GCF is on the left, and then what is on the bottom is our leftover stuff. So when we're rewriting this to make it look like the very beginning of distributive property, because remember that's the whole point of factoring, is that we're working backwards to make it look like the beginning of distributive property. Step 3 tells us that GCF is on the left, goes on the outside of our parentheses, and on the inside should be what's left over, which is our 2 minus 5x. So our final answer should be 5y times 2 minus 5x. All right? Let's look at this last one real quick because this one's a little tricky. All right? Because I have this squared. Now, is there a number that I can pull out of here? Can 5 be divided by a number that 7 can also be divided by? Well, no. So I'm not pulling out a single number, but I am going to pull out a variable because they both have x's. So I'm going to pull out one x. Okay? I'm just going to pull out an x. Well, I already know that I'm not losing my numbers because I'm not dividing my number by anything, so 5 stays the same. So here's the thing about x squared. X squared is the same thing as x times x, right? Well, if I'm taking out an x, I'm getting rid of one of those x's, right? So how many x's am I left over with? Just 1. So that is going to wind up being just 5x. Okay, and then I'm going to write my minus sign. And then again, I have 7x. I'm not dividing 7 by any number, so that stays the same. So that's just 7. But then I have this x, and I'm pulling out 1, so it's like me getting rid of that x. So now I'm just left over with 7. So again, GCF is on the left. The very bottom is what's left over. My x, because it's GCF, goes on the outside of my parentheses. And what's left over of 5x minus 7 goes on the inside of my parentheses. And that's how you factor expression, guys. Okay, so real quick, I want you to try this last problem on your own, and then these are for homework, and you do have one extra activity to do today. It's going to be a short quiz, and all that quiz is going to be over is 1A, 2A, 3A, and 4A, and you can actually use your notes to help you with this quiz. All right, so don't forget about that. These are going to be the exact questions on the quiz, and you can use your notes to help you with that. Have a great day, everyone.